In this video, we are going to look at type 1 and type 2 errors. In hypothesis testing, we're going to check to see if the null hypothesis is true or not. And that means we are either going to not reject the null hypothesis or we're going to reject the null hypothesis. So let's come up with a null hypothesis. And again, I'm completely making this up, so I have no idea if this is true or false. It sounds pretty plausible though. The average age of the typical college student is 20. So we take all the college students and add all their ages up and divide by the number of college students. The mu would be 20. Now, that could be either true or false. What if it's false? What if 20 isn't the average age? Well, then we should reject the null hypothesis. And we would probably do testing to show that it is indeed false, and then we would have made the correct decision. Now, what would happen if we decided to reject that premise and it was actually true? Well, then we would be making something called a type 1 error. You can use Roman numerals if you like, or you can just use normal digits, but the book will use Roman numerals from time to time, so just get you used to that. Now, what would happen if you did not reject the null hypothesis? Because when I said to you, oh, the average age of the college student is 20, you went, okay, that makes sense. And then you did some testing to reinforce that. Well, you're now making the correct decision again. Awesome. Now, there is a situation though where that would be wrong, but you're deciding to hold on to it and saying like, no, 20's got to be right. Now you're making a type 2 error. Type 2 errors are not what we're going to be doing in this unit, but I do need to talk about it just so you're familiar with the differences between a type 1 and type 2. Now, what's nice about this is I have this in front of us so we can kind of compare and contrast. A type 1 error is when you reject the null hypothesis when it's true. Now, what about the type 2 error? This is when you do not reject the null hypothesis when it's false. Now, there's a Greek letter that's associated with the type 1 error, and that's alpha. We've seen alpha before, haven't we? We've seen alpha before in our confidence intervals. So let's now talk about the alpha again. The alpha is the probability chance of making a type 1 error. That's what alpha is. And if you subtract alpha from 1, this gives you your level of confidence. And you've seen that level of confidence before with your confidence intervals, or CI. So in previous problems, you had like 99% confidence, so your alpha would be 1%, or 5% confidence, and then your alpha would be 5%. Okay, so in a type 2 error, the Greek letter is beta, and that beta is the probability of making a type 2 error. Sorry, this is having such a tough time writing. Now, if you go 1 minus beta instead of 1 minus alpha, this gives you the power of the test. And of course, the bigger the number that this is, the better the test it is. And this is more for informational purposes only. We won't be using this for the work that we're going to be doing, since we're going to be testing for type 1 errors. We're going to be testing to see what is our chance of rejecting the null hypothesis when it's true. So for this first of 3 examples here, we are going to describe the type 1 or type 2 error, and we're going to basically use the given statement that the null hypothesis is that we have safe climbing equipment. So I found that trying to do this in my head isn't so great. So just making this chart on a separate piece of paper is super handy, because here I can say, okay, if my null hypothesis is that I have safe climbing equipment and the null hypothesis is true, then my equipment is safe. And that's awesome. Now, what if the null hypothesis is false? Well, that's then going to be unsafe. Well, so now everything in this column is going to be unsafe and everything in this column is going to be safe. Now, rejecting the null hypothesis would be to don't use the equipment. Okay, so don't use. And do not reject this null hypothesis means we're going to use it. We're going to use the equipment. Okay? So, just like up above, this is the correct decision, because we're not going to use the unsafe equipment. And this is the correct decision too, because we are going to use the safe equipment. But a type 1 error, so right here is the, again, we'll put here type 1, okay? So now I go across from the don't use and down from the safe, and a type 1 error is when you don't use the safe equipment. Okay, so that is an example of making a type 1 error. Well, over here is the type 2 error. Okay, it's type 2. And again, I can go down from this column and over from this row. And a type 2 error is when you use the unsafe equipment. Now, both of these are mistakes, but one of them is definitely worse than the other. Not using the safe equipment, and probably in turn of using other safe equipment, will probably be better than using the unsafe equipment. For the second of 3 examples here, we're going to take a look at treating somebody who might be sick. So, the null hypothesis is that the patient is not sick. So this is when making the table is so useful to us, because you can put in the table a negative statement, and that negative statement you can kind of keep track of where it is. So this is not sick. And then, of course, if that's false, then the patient is definitely sick. Now, this means that we're going to basically treat the person here. Rejecting means we treat, okay? And do not reject, because the thing is, if we have a not sick person, then not rejecting the null hypothesis would be the correct result here. This is do not treat this person who is not sick. And we would also treat a person who is sick. So here's our type 1 error. And here's our type 2 error. And the type 1 error is this problem. This is when we treat the not sick person. It's a mistake. We treated someone who wasn't sick. Hopefully the treatment didn't, have any side effects, but that's again usually we're usually not giving any treatments that would have side effects in any way. Just unnecessary tests. Keep the health insurance down, right? All right, now I'm just playing around. doing some doodling, trying to make that when look a little nicer. My brain just wouldn't let it go. Not a big improvement. Okay, type 2 error. A type 2 error is over here. This is when we do not treat the sick person. And this follow-up question asks, which might be a more dangerous conclusion? Type 2 error is definitely more difficult here, especially if that treatment would prevent the spread of something. So yes, definitely, type 2 is definitely worse. Treating the not sick person, definitely not as bad as not treating the sick person in this second of 3 examples. All right, in this final example, I wanted to throw another situation where instead of us testing mu, which is an average, we're testing a percentage. Yeah, you see, this is a null hypothesis that claims that something is at least 75% effective. So this is not an average. This is p sub 0. And p sub 0 is our percentage null hypothesis. So this is p, you could put a p instead of these h's here. But let's just kind of treat this as our null hypothesis percentage test. Okay, so if the null hypothesis is true, then this is greater than or equal to 75%. Now if it's false, it's going to be less than 75%. Notice I have a greater than or equal to. Null hypotheses always have greater than or equal to's, if it's false, this would be less than. You can't have two equal to signs, because what if it's exactly 75? Okay, so if it's false, we should reject. That's the correct decision. And if it's true, we should not reject. But here's your type 1 error. All right? What we should have done is we should have not used it, right? Don't use it if it's not 75% effective. But in this situation, we decided to use it anyway, because these two are opposites, and this is our type 2 error. So our type 1 error is we do not use it, though it's greater than or equal to 75% effective. So we should have used it, but we didn't. That's a type 1 error, and that's what we're going to be checking against with our alpha. Now a type 2 error is when we use it even though it's less than 75% effective. Okay. Now in this situation, I would say the type 1 error is worse, because by using it, it would probably, whatever it is, it could be a remedy, it could be something that's useful for a machine or for your home processes. But here the type 1 error is probably worse, because we should be using it unless the type 2 error is safety equipment. Because the type 2 error, if we use it and it's less than 75% effective, like maybe brake pads or airbags, maybe a type 2 error would be worse. So it's kind of a judgment call there. But this gives you the idea of how we can look at type 1 and type 2 errors, and it's just so much easier. Please make a table. Trying to do so without making a table is going to make things really tough. Well, thank you again for watching the second video on the introduction to hypothesis testing.